Hello and welcome everyone to the fourth live session for the 02 Certified IPv6 Engineer in 21 Days workshop. As usual, we're going to invite you to go to menti.com and enter that code 53521 4270. You go to menti.com, or better yet, you can scan the QR code on your screen. Exactly, we want to have an idea of where our audience are joining us from. So I believe it's a good afternoon from South Africa. Good afternoon, Sudan. Good morning, Nigeria. I'm not sure if it's good morning or good afternoon in Somalia. Okay. How many of us are in here? 59, and 16 have voted. So it's mostly good afternoon, and a few of us a good morning from wherever you're joining us from. The majority who have voted are from South Africa. Thank you very much. Okay, so as usual, again, we'll quickly go over the very simple basic house rules. As usual, the three icons at the bottom of your Zoom client. Use the chat section, looking at the chat right now. Use the chat section to comment or say anything or raise questions or issues about the quality of the stream. So the audio or the video. If you have difficulties or challenges with that, or you're experiencing technical difficulties with that, please use the chat section for that, okay? Anything pertaining to this stream, technical, for the audio or visuals. Now, use the Q&A feature to ask questions about what the presenter is talking about the topic, all right? Today is about IPv6 routing. So use the Q&A feature or post your questions in the Q&A section. Like I said, it's easier for the host and the co-host to manage questions that way, rather than putting them in the chat, all right? And then finally, if you want to ask a question with your voice, you can use the raise your hand feature, and one of the hosts or co-hosts will allow you to speak, all right? So, ladies and gentlemen, welcome again to live session 4. Before I go forward, I'm going to go over a few announcements. I know all of you probably here received the email communication from us yesterday, informing you that the learning platform is back online. And there were next steps, actions you had to take. So we expect you to all have completed all the courses, the 70 courses, taken and passed the final exams or the final quiz, which has an 80% pass mark, all by the 25th of October. So, all the ladies and gentlemen who have been the top 5, for example, in the competitive quiz we've been doing, and those who were in the lucky draw, the 2 lucky winners doing the lucky draw, you only get to benefit that, take advantage of that benefit if you complete the course or the workshop on time. So what I'm saying in other words is that for you to get the 100% discount, if you've been in the top 5 since the beginning, during the live sessions, is that you need to earn all the 7 badges for all the 7 IPv6 courses on the e-learning platform, all right? So you have to do that on or before the 25th of October, all right? So the on-enrollment automations are back on. So if people are not making progress, they will be automatically on-enrolled. So we've, like I said, the platform is back online. We've stress tested it. We are comfortable. We are confident that it's going to hold now, and we've, advertised it back to you. So like I said, for you to take advantage of that, of all the perks that come with attending these live sessions, you need to complete those 7 courses and earn, not just complete, earn the 7 badges. When you earn a badge when you pass the final quiz for that course, all right? And for you to pass, you have to get a pass mark of 80% and above. All right, so let's see. Today's session will be by, I don't know if you can see the gentleman next to me on my right. This is our veteran trainer, Musa Stephen Onwe. And now, who better than to walk you through IPv6 routing than the author of the e-course itself on the learning platform. When you go after the session, when you go over to take the course, you will see that he's the author of that section. So Musa Stephen Onwe will be handling this session today. So before I invite Stephen, let's just quickly go over the agenda quickly. So Stephen will be teaching, giving you an overview of basic IPv6 routing, and then we'll open the floor for questions. And as usual, we invite you to take a survey, and then finally, we will spin the wheel to get the lucky winners. Now, of course, during the session, there'll be a quiz. There will be a quiz for us to select the top 5. Again, please enter your real name, your first name and your last name, the name you used to register for this session, all right? It's easier that way for us to track who are the top 5 learners. All right, with that said, I will hand over to Stephen.
Merci, thank you very much, Mr. Oletunde. Can you hear me very well? If you can hear me, please type in the chat.
Yes, you can use the chat section for that.
If you can hear me, use the chat to say hello.
Loud and clear.
Loud and clear. Thank you very much. That's good. I need to see you people in here. Thank you. So far, we have 61 people in the chat and in the room. And I want you to be very, 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 very active in this session. I love active sessions. I don't like speaking too much when I don't have people speaking back to me. So your way to speak back to me is by using the chat. And I'm very, very impressed by the countries where you're joining us from: South Africa, Malawi, Kenya, Nigeria, South Sudan, Chad, Benin, Somalia. All right. So yeah, it's quite interesting to have you all here today. And this session is quite an amazing one because we don't have a lot to share with you. Honestly, we have nothing much to share with you. Why? Because I am guessing you already know all about routing. If you've been running networks, it means you've been routing in IPv4. So back into the chat, please let me know, on a scale of 1 to 10, how confident are you with routing IPv4? On a scale of 1 to 10, how confident are you with your skill? Amazing. Tens. Oh, yeah, this is interesting. Good. Nines, 11. Oh, there are people above 10. This is the guru. Maybe I should pass over the course to him to teach us. Oh, there are fives. Okay. So thank you for this. Now, a next question, as you as you must have noticed, there is a two. I am sure this person is humble. As you must have noticed now, I love asking questions. So my next questions for you is, when we talk about IPv4 routing, what comes into your mind? When we talk of when we say IPv4 routing, what do you think of? What key feature do you think of? Type in the chat. Routing table, okay. Static routes, OSPF, routing protocols, IGPs, EGPs, static dynamic routing protocols, nothing, routing tables, BGP peers, OSPF, etc., static routing, and so on and so forth. Okay, I have a last golden question for you. If you have to say one thing about how we decide to select the best path, what will you say? Communication process of forwarding. Yeah. If this person fell into my trap. Hey, this is Mr. Can I? This is Why is that? I missed him, eh? Somebody typed there about forwarding, something like that. It's not easy. Yeah, that one. I will not call your name. Process of forwarding data packets between devices on the internet using routers. It's quite interesting, huh? When I thought that was my last question, but now you push me to ask another question. Do you make any difference between routing and forwarding? Do you make any difference between routing and forwarding? What's the difference between routing and forwarding? What's the difference between routing and forwarding? Are they the same thing? What is the difference? Routing happens before forwarding. Good. Forwarding uses the forwarding information base. Good. Nothing. Routing and forwarding are not the same. So what's the difference? No, there is a difference. What's the difference? Routing makes decision about which path to forward. Exact. Good. Yeah. So before I dive into the slides, oh yeah. Okay. Thank you very much. Thank you very much. I love this session. It's quite interactive. I love this session. So, as you all rightfully put, routing is the process of building the topology map of the network. All right? It's done either statically or dynamically. All right? So you have static routing and you have dynamic routing. You all said it. I'm just summarizing what you said. Static routing versus dynamic routing. So routing is the process of informing the, call it what you want. Some people will call it the routing table. Some others will call it the forwarding information base, and so on. So the process of getting network reachability information and storing in a particular table to inform the router on how to go to network X, how to go to network Y, and so on is called routing. We can do it manually. That is, we go to the router, we type to go to network S, use this hop. To go to network S, use this exit, and so on and so forth. Or we can do it dynamically using routing protocols. And in terms of routing protocols, you rightfully said that we have IGPs, that is interior gateway protocol, and you have EGPs, that's exterior gateway protocols. All right. Interior means is in the network and an autonomous system. Let's put it like that. So if you have your network, like us here at Afrinic, we have a very large network, and this our network, we are using an IGP within it to route between our internal routers. Now, the internet is a collection of networks. A network A connects to network B, connects to another network, and so on. And then we form a web like the spider web. And for this network to interchange reachability information, they use what we call exterior gateway protocol. And right now we have only one that is used. It's called BGP. So, and you are looking at my slide there. So we'll be talking about static routing. We'll talk about one IGP, that's OSPF for IPv6. And then we are going to talk obviously about BGP, because if there is only one routing protocol we wish to talk about, it will be BGP, because that's what is holding the internet. Okay, so let's move to the next slide here. And there is probably a quiz for you, I'm sure. I said it. All right, so this quiz, let's start the quiz.
So remember, join with your real name, first and last name. Do not close this tab, okay? The tab you used to join the quiz till the end of the session, all right? So you can scan the QR code on the screen if you want.
Not that one, this one.
All right.
Oh. Hey, we have 66 people in the room. Everyone join the quiz, please. 43. Please join the quiz, everyone. 45. We still have 20 people left. Join the quiz. Join the quiz. 45, 21 participants left out. 20 to go. Oh.
Dropped off. So, okay, 47 now. So,
Do you want to run it like this?
yeah, I mean, it's almost the full set. So, yeah, so 48, let's start it then.
Are there others going to be able to join also?
Yes.
Okay.
You can join after.
So, first quiz question. You have it, and there is a timer. You don't have the whole day. So, which of these are features or concepts in IPv4 routing? When I queried your knowledge of IPv4, you were very skillful. You know it all. I can assure you. Now, these features that you have there, pick which one is a feature of IPv4 routing.
I have 14 seconds left.
All right. Thank you. Thank you very much. So we have 10 right answers. Maybe 10 or less. Okay. So we are going to show the leaderboard. And you can see that out of these 4 features that we displayed there, we have only 2 that are good. All right, so the administrative distance is obviously something, right? And you have the longest match for prefix forwarding. Actually, when I ask you during the introduction, what one feature would you say about routing? It should be about the prefix match. What is the best decision that what is the how will I say the metric, all right, or the parameter that a router will use to take a decision for if it's having various routes to the same network? It will use the best prefix match. All right, it will use the longest prefix match, not the shortest, the longest. All right, and administrative distance is something that is used mainly in HOPE protocols. Okay, so MAC address, no, MAC address, we are at layer 3 here, remember? routing happens at layer 3. MAC address is at layer 2. We don't deal with MAC address at layer 3, okay? We deal with MAC address when we are doing direct communication. So if two of us, we are on the same link, call it segments, what you used to call segment in IPv4. If we are on the same segment, we communicate using our MAC address, okay? It's also called layer 2 address. Good. So let's move to the leaders board to see who is really leading the league at the beginning of this competition. Okay. Good. Good. All right. So Ruanel, 962 points. Good. All right. So I already discussed this, right? So why I was saying that we don't need this session is because I know you already master IPv4 routing. So there is no pretty much you have to learn in order to start doing IPv6 routing. Basically, the key principles apply in IPv6. All right. Remember in IPv4, if you had two routes to the same network, what will you pick? You pick the longest destination match for the prefix. And routes can be static or dynamic, right? As I said, you can, the network admin or engineer or technician can do his routing configuration manually, okay? If you have GNS3, you can try. Administrative distance still applies in IPv6 routing, and the distance vectors versus the link state protocol still applies. So we still have all of those protocols. We still have RIP, OSPF, ISIS, what else? EGIP for the vendor specific protocols, and so on. So we still have all these protocols, both the distant vectors and the link state protocols. And your knowledge of those two still remain. Like distant vector, they still rely on hope, on the hope, right? The number of hope to get to a destination. If I will use 10 hope to get to a destination versus I can use 6 hope to go to the same destination, I'll prefer 6 hope. That's how you prefer in distant vector protocols. Meanwhile, link state protocol will study the state of the link that is leading you to a destination. So if I have concurrent paths, path A, path B, path C, path D, I'll pick of all these paths, the one with the best quality that can get me to the destination. And this best quality depends also on the parameters that you are going to specify as a network engineer. Now, let's look at the best practices, right? The best practices in IPv4 used to be what? We said we have IGPs and then we have EGPs. So what's the use of IGPs? Examples of IGPs are OSPF, RIPE. That's, I don't know if it's RIPE or RIP actually.
RIP.
RIP, okay. So for it to be RIPE, I have to add.
It has to be a fruit.
Oh,
No.
okay. So it's RIP. By the way, I used to call it Rest in Peace Protocol.
So Stephen is a French speaker, sorry, but go on.
Yeah, that's why I'm having this broken accent and the wrong choice of words. I hope I make sense though. So IGPs are used to carry your infrastructure addresses. That is to configure your mesh, the mesh topology of your network, to make sure that all your routers can reach each other. That's what the IGP is used for. Carry your infrastructure addresses. Remember, infrastructure addresses, not prefixes. Because this is something people do sometimes. You share your infrastructure prefixes on using an IGP. We even see some people doing IGPs, that's configuring OSPF with their customers. That's very bad. Don't do that, right? You don't do OSPF. You don't do RIP with your customers. You don't do ISIS with your customers. You don't do EIGRP with your customers, right? You configure these IGPs within your autonomous system. And sometimes, if your autonomous system is very large, you don't even want to do that like globally. All right? You don't want to do that globally. So the IGP stays in your network. There are many reasons to that. First of all, it's the efficiency. Secondly, is the scalability. Third is the security. Most importantly, the security. You know, routing protocols carry information about your network, right? If you have to share this information about your network, reveal it to your customers, you don't know who is sitting in your network, in your customer's network. What are their intentions? So if I can sniff and have the information about the topology of your network, there is a way I can go around that network and reach whatever I want. If you're having firewalls in your network, there is a way I can do firewall evasion if I know the topology of your network. And it's very easy to know the topology of your network if I have packets that are shared by your OSPF, for instance. You remember, OSPF has the entire map of the network, and this map is shared with all the OSPF speakers. So if one of your OSPF speakers is sitting in a network that you have no control, imagine what? Yeah, I guess you imagined. So you have to minimize the prefixes, right, in your IGPs. An IGP like OSPF, each time it is called link states, right? What that means is each time there is a change on a link, OSPF will announce to the world, right? Not to the world, to all the speakers in that OSPF topology. We used to call OSPF the chatty protocol or the gossiping protocol. It acts like some of our women. Yeah, sorry for that. Okay, so this is the IGP, and this is what you know already in IPv4. This applies in IPv6. So if that's a knowledge you have already, just carry it over to IPv6. Welcome to IPv6 with this knowledge. You are good, comfortably seated. Now, in terms of exterior gateway protocols, we have BGP. And the way we use BGP is either in the autonomous system that is in our network or outside of our network, but mainly outside of our network. Now, let's look the difference between what we call IBGP and EBGP. I stand for interior BGP, all right? And interior BGP means what? So, if you have a large network with you, how do you call POPs, points of presence everywhere. Let's say in a city you are having 10 points of presence, and then you are not limited to that city. You also connect with another city. City A connects with city B, connects with city C, and so on. And then you even have networks out of the country, right? What you will do is at each point of presence, you have to configure like a standalone network. You have a standalone network. Now, this standalone network needs to communicate with another point of presence, which is another standalone network of yours. How do you link these two together? You link these two together by using IBGP, interior BGP. So what are the characteristics of interior BGP? Interior BGP carries either your customer's prefixes or your backbone prefixes. I just said you're having point of presence A and point of presence B. You went to Afrinic and you had a very large prefix that you divided into two. one at point of present A and another sub-prefix at point of present B. How do you interchange these two prefixes so that the two networks know each other? You use IBGP, all right? You configure IBGP between the two sides of your network. And you do this for all your sites. Take the scenario where you are present in a country with 10 cities and you are present in, let's say, 8 or even all the 10 cities. In each of those cities, you are having a network. When you take your global prefix from Afrinic, you are going to break it down in various small prefixes that you are going to configure in each of these cities. Now, for all of them to speak together, you first have to configure. First of all, you have to connect them, right? Maybe physical connection or wireless connection. When you now connect them, you need to use to configure the various gateway routers, right? The border routers to speak to each other. When they cannot speak to each other, you've done maybe a mesh topology, because to get to maybe city 1 can reach to let's say at least can connect directly to at least 3 other cities. This is to make sure that you have redundancy. And when you have this redundancy, you want now to go back and configure your IGP to make sure that the loopback addresses that you are configuring on these devices can be reached from anywhere at any time. In case there is one link that falls down, that breaks, what will happen? You have to be able to still reach that router using another link. After you've done this, you can now configure your IBGP to carry your infrastructure prefixes. That's IBGP. Now, EBGP is used to communicate, not communicate. We used to say communicate. Yeah, at the end of the day, it's communication, but it is used to share network reachability information between your network and other networks. And if you were sitting in front of a router and you saw like BGP configuration, and I'll ask you, oh, what is this? Is it IBGP or EBGP? You should be able to tell, right? Looking at the autonomous system number, okay? The autonomous system number in IBGP is the same for all the peers. Meanwhile, for exterior, the E stands for exterior, not external, exterior. For the exterior BGP, the autonomous systems are different. Afrinic is connecting to MTEL. We do a BGP session. MTEL will give us their ASN, their autonomous system number or ASN, and we'll share our own autonomous system number to them so that we can now configure. So there are other lot of principles. And there is one golden principle that I love to talk about when I talk about BGP. Or maybe I'm going to talk about it later. Or yeah, let's just move on. Let's just move on here and look at the next slide. While we are speaking, if you have questions, please don't hesitate to ask for the questions. My colleagues that are online are going to assist, or we can pick them on the mic and, yeah.
No, the first few questions are pertaining to the way the workshop runs. So we'll answer that at the end of the workshop.
Okay.
But this one from Gujo, I don't know how relevant to say what happens if you disable IPv6 firewall.
All right, this has nothing to do with routing, but yeah, it's still IPv6 and it's IPv6 security. Oh, by the way, if you decide to live in a house without doors, you know what will happen, right? So if you disable your firewall, a lot of things are going to happen. Firewall is not an option in IPv6 or in networking. You must be running a firewall because that's how you protect yourself from various threats, right? Malicious attacks, things like that. You need viruses, things like network spoofing, things like injecting in your network. All of these things, you protect against them using firewall. So by the way, when we talk about security, we do security at many levels. At many levels, each component basically that you configure in your network, or each protocol that you configure in your network, you have to tie the security. If I'm configuring BGP, I need to secure BGP. If I'm configuring OSPF, I need to secure OSPF. If I'm configuring DNS or the time protocol, the NTP protocol, if I'm doing voice over IP, I need to think of security at every layer and every aspect of my network. All right. So yeah, if you disable IPv6 firewall, make sure that be ready for us. We are going to come after you, and you are going to be shamed on the internet because your network is going to be a bad example. Good. And now for this question again, let me even go further. Now, people might be thinking, oh, I am not running IPv6, so I don't need to secure IPv6, right? That's bad. Because some of the vendors, some of the softwares, some of the operating systems come with IPv6 enabled by default. If you don't, when you are configuring your network, if you don't block IPv6 specifically, things might happen in your network. So always make sure that if you are not running IPv6, it is completely down on your network. And if you are having a firewall, make sure that since you are not having IPv6 in your network, make sure that any IPv6 packet coming in or going out, shut it down because you are not doing IPv6, okay? Yeah. Thank you. If my point of presence are standalone, that is, I don't own one links between them, do I configure IBGP or EBGP? So if you don't have a one, if you don't have a one, you just it's like independent units, right? You're having independent units. So um you might still you might use tunnels, right? You might use tunnels to have like direct links. So it doesn't have to be physical links. When we say connected, it doesn't mean that you are connected directly. You can have all your sites can be connected directly to the internet, but you still configure the direct links, either using MPLS, or if you are having the same upstream provider for all of these networks, you can manage for them to do like direct links, not direct links, like make sure that your networks appear as being a one. All right, you don't have to, invest in physical connections. Okay, thank you. Now, when you say, because when we say IBGP, right? IBGP, you don't have to be directly connected. Meanwhile, EBGP, you must be directly connected. That's the difference. EBGP, you must be directly connected. IBGP, you don't have to be directly connected. So even if you don't have those direct links, as I said, you can still do IBGP over the internet, right? That's possible. Merci. So we are going to launch the next slide, which is a quiz. And yep. All right. So 50 players out of 69. Where are our other friends? I hope I didn't kill you by PowerPoint. 53, 13 to go, 54, 56, 57. Ah, this is interesting. Can we hit 100%? 58, 11 more. Okay, well, just let's move. No hope.
All right, so this question is a bit related to some of the things we talked about in the past, but so what is the prefix and prefix length on IPv6 default static route? All right. I think most of us got it right. Okay. Yes, ::/0 matches all. All right. So let's look at the leaderboard. Let's see if Ruan is still the one on top. Drone. Still the one on top. All right, so not been dethroned yet.
Bravo. Thank you. And let's move on. So the diagram on the screen is displaying the configuration of IPv6 static routing or static routing for IPv6. Yeah. So with Cisco routers, I don't know if with recent iOS is the case. By default, routing is not enabled. All right. So routing is disabled. This is a security measure. So you have to explicitly configure enable routing. And the way you enable routing is by typing the command IPv6 unicast routing. Now, to configure a static route, you remember how you did it in IPv4? You have to specify the destination network and the IP address of the next hop or the exit interface. The principle stays the same. The command is IPv6 route, the destination address, that is in this case, we have 2001 : db8 10 /48. So it's a /48 network. And the next hop. So to get to that destination, you need to send the packet to 2001 db8 : 2. That's for router 3. So for router 2 there, you type the same command to enable IPv6 routing, IPv6 unicast routing, and then you enter the command to create that route. So for each of these networks, what is happening here is for network 2, that's the network at the other hand, here, this network. For this network, to get to this prefix, that's 2001 db8 20/48, you need to send the packets to this IP address, that's 2001 db8 : 3. So when you create this on this router, all the devices sitting on this network, when they want to reach this destination, they will send to the router. When it comes here, this route is sitting in the forwarding information base or the routing table. So the router is just gonna look into the routing table and know, oh, this is where I'm sending this packet, and it's going to send this to this router. The router is going to look at what specific host in the network is the recipient of that communication, and then it's going to forward it to it. Now, when you configure this static route here, it is a asymmetric route. The other network also has to teach its router how to get back the packet to this prefix. And that's what we did here. All right. So This is how you do static routing. If you have any questions, I'll be willing to take.
Let me just add, if I can.
Okay.
That's something. Okay, so with the IPv6 unicast routing command for Cisco iOS, I think for FRS IPv6 forwarding, normally in IPv6 or these routers, they behave like just a node, just like any PC. So you have to, specifically enable them for IPv6 routing. So when you put that command in, the router is going to join the all IPv6 routers on a local link, F02::2. Remember that. You can start sending router advertisements out of this interface now, and you can configure a dynamic routing protocol on it. All right.
All right. Merci, Monsieur Olatunde. So moving to the next slides, we are going to look at OSPF. So you remember for V4, we said we had many routing protocols. My best routing protocol is ISIS. I know OSPF is very cool. It's known by everyone, but I prefer ISIS for some reasons that I'm not going to disclose here. Yeah, it's agnostic, it's an agnostic protocol. So you see this in Nigeria, we say wahala. This trouble that we are having here, figuring out how to configure OSPF for IPv4 versus IPv6 versus maybe other VPNs and so on. We don't have that problem with ISIS. We just go straight forward. We activate ISIS and boom, it picks all infrastructure addresses and then starts routing them. So it's very easy. It's very convenient. It's very scalable, right? Now, let's talk about OSPF because I know if I'm querying this class now to look at how many of you know OSPF, I'm sure 100% knows. But if I'm talking about ISIS, it's kind of maybe there will be a reluctance among our participants today. So yeah, OSPF for IPv4 version 2 cannot do IPv6 routing. So a new version of OSPF had to be created. That is OSPF version 3. And in this OSPF version 3, some enhancements happen so that we can support IPv6 address family. So one of them is, the first one is that I guess LSA, that is link state advertisements. You know them, right? So this is how routers in an OSPF network share information between each other. They do what we call link state advertisements, right? Using link state updates. So you have 8 types in IPv4. In IPv6, the link state type 9 was added to carry prefixes only, right? To carry prefixes. For IPv4, when you do OSPF routing, you do authentication directly in your configuration. In IPv6, you don't do that. You cannot. There is no possibility to do that according to the RFCs. So how do we handle security? You have to do either authentication header or encryption packets, right? So you have to configure using AH or ESP extension headers. In the introduction course, you learned about extension headers in IPv6, and you saw that there was authentication header and encryption headers that you can use to configure things like VPNs or to secure your packets. The third parameter that we need to talk about here is that OSPF version 3 operates per links. Remember what is a link in IPv6? Is what we call a segment in IPv4. All right. And on a link, on a specific link, you can have thousands of IPv6 networks. You can have thousands of IPv6 subnets. So what you will do on a link is that you will enable IPv6 OSPF version 3 for IPv6 routing on a link, and is going to handle all the subnets existing on that link. So it performs per link, not just per subnet, as in IPv4. So on a link, you can have many instances. No worries, no wahala, right? And you can choose to exclude some routers on some instances. So it's very cool, though. You can decide that, oh, although all these routers are on the same topology, this subset of routers are speaking these things about OSPF, and this other subset are sharing OSPF. It's kind of, it looks like ISIS, though. We are getting there. So it uses LLAs. What's that? Link local addresses, right? You remember link local addresses, the FEATs. Remember in the introductory course when we're talking about the link local addresses for neighbor communication. And this is something that's very cool about IPv6, it was meant to operate out of the box, some sort of plug and run protocol. Yeah, that's how IPv6 is cool. So if you decide that, oh, I've put all my devices, and this is also a risk, it's a challenge. This is where we are now giving space to people who intentionally run their networks. In IPv4, people sometimes they rely on things like NAT to say we are doing security. No, in IPv6, you have to be the guru, the master of your network. So out of the box, when you plug in a device that is the interface card of a device on a network, when you plug that in on a network and IPv6 is enabled, what happens? That interface has a link local address already and can start communicating. All of these system mechanisms that are happening on the network relies on the link layer, link local address. The link local address, like link state advertisements for BGP networks, for OSPF networks, even BGP neighbors in an iBGP configuration will prefer to carry those information on a link local address. Isn't that cool? Isn't that cool? I need to see in the chat if we are still alive.
The top guy, everyone says it's cool.
Ruan. Yeah, this is interesting in terms of protocol. So, by the way, why are we still running IPv4 networks? Yeah. All right, so there is a question in the Q&A, and the question says, can you please explain link versus subnet? Okay. Link versus subnet. This is already two different layers. We are talking about two different layers. If we are talking about subnet, at what layer are we of the OSI model? What layer do we talk about subnetting? In the chat, please. Subnet, layer 3, layer 3, layer 3, layer 3, layer 3, layer 3. Oh, I can actually make a cool song of this. All right, layer 3. So we know subnetting happens at layer 3. Network IP addresses is at layer 3. Meanwhile, the link is layer 2. So if you are having a switch, right? a switch. If you are having a switch on which you connected all your devices, right? All these devices are in the same, guess what? Guess the word. In the chat, guess the word. The same, all devices connecting on the same switch are on the same broadcast domain, not subnet. They are not on the same subnet. We can all connect on the same switch and we are in different subnets, right? We can connect devices on the same switch and give them different subnets. When we connect on the same device, on the same switch, or on the same SSID, we are on the same broadcast domain. A link is a broadcast domain. It can be a VLAN. A VLAN is a broadcast domain, right? A link is the same broadcast domain, all right? Not the collision domain. No, it's not the collision domain. The collision domain is lower. The link is layer 2. So I guess I don't know if this explains it well to you. They are on the same solicited multicast. No. Nah. I will not explain solicited multicast here. I will leave that to Olatunde to explain later. Yeah. All right. So the link is at the layer 2 level where we are on the same broadcast domain. So you see at the level of a broadcast domain, we can have many subnets. We can have many subnets on the same broadcast domain, right? But all these subnets cannot talk to each other. They cannot talk to each other because they are on different subnets. When I say they cannot talk to each other, I'm talking about layer 3 communication. But at layer 2, when we are in the same broadcast domain, we can send information to each other because there we are talking using our MAC addresses. I hope that's clear. I will now give the floor to Mr. Olatunde. Difference between pay link and pay subnet. Okay. So difference between pay link and pay subnet is this. So I just said that a link can have many subnets on it, right? A link can have many subnets on it. On that subnet, on that link, let's say you are having 1, 2, 3, 4, 5, 6 subnets. If you enable IPv6 OSPF routing on that link, it can handle all of these subnets. That's why we say it's pay link. Now, what you have to do as the network admin, you have to go specifically and tell the OSPF process which of these subnets you want to route and exclude the one you don't want. In IPv4, we operate per subnet. So if I'm having 6 subnets, as I said, on a specific router or on a specific switch, what I'm going to do is the OSPF that I'm going to configure is going to operate for each of those subnets. It's not going to go by default and advertise all those subnets. This is why when you do OSPF in IPv4, there is a command network. You have to do network and specify the subnet that you want to handle. Right? When you enable IPv4 OSPF on your router, you have to go in the process and say, I want this network, I want this other network, and so on. Good? Meanwhile, in IPv6, you don't have that network command, right?
I don't know, maybe I should ask you a question.
All right.
Does it have to do with being able to assign more than one IPv6 address on an interface?
Yeah, but you know, for IPv4, you are also capable of assigning more than one IPv4. Although for IPv4, you have to specify that it's a secondary IPv4 address. So for the enhancement is not much about the capability of having more than one IP address. Is for scalability. It's for scalability, because remember, in IPv4, what you did is you configure the IPv4 process, and then you have now to come manually in that process and specify all the networks that you want to be routing. In IPv6, you just have to enable it, and then all the networks are in. Then you now have to go and say, it's like, consider it like a wide list versus a black list, right? IPv4 is like a wide list. Meanwhile, IPv6 is a blacklist, right? You have to go and remove those that you don't want in that list. Merci.
All right. So I think we have a quiz coming up, if I'm correct. So let's see. Six players. To hit 50 before I started. Okay, so we're at what, 53? All right, so I'm going to start the quiz now. So you see the question on your screen. Which of the following multicast address pair is used by OSPF v3? Okay, so as you can see there, correct answer. Okay, so for the first one, those are the IPv4 equivalents. So you could have easily mapped them to IPv6 to end with :5 or :6, just like you have .5.6 on for IPv4, right? And if you remember from the previous sessions, 0202 link local scope, all right? So about :5, just like .5 for IPv4 is for all OSPF routers, right? The point-to-point links. And then for the designated routers, :6, F02:6 for the designated routers on the multi-access segments. So definitely the one you see with 29 correct answers there is the correct answer, right? Okay, so let's check the leaderboard if the gentleman is still on top there or he's been dethroned. One.
He's still there. No. Ian.
Wesley. So Wesley Strickland is the top now. Okay. So the faster you vote, the faster you get the points. So before I move on, so let me quickly answer the question by Robert here. I said I was answer at the end, but let me answer now. So he said about the top 5. Do you get the reward ones for being in the top 5? Because the last mail does not feature me for the second time, although I was in third place. So that is correct. You get it once. So yes, I mean, of course, we appreciate your participation because you've been in the top 5 twice. You can't have it more than once, all right? So we give room for people who are either below you to select to push them up, okay? So for the top 5, because you've already gotten it the first time, all right? So you're in the top 5, you can't get it 100% twice, all right? Anyway, I hope that answers your question. Let's move on.
All right. So let's talk about link state advertisements from OSPF version 2 and their similarities with those in OSPF version 3. So OSPF, so remember, to do OSPF for IPv4, you do version 2, and for IPv6, you do version 3. So type 1 is called the router LC, right? And this router LC describes the router's link state and cost. That is, I know you remember that in OSPF, we have what we call areas, right? And we can have OSPF with one area or more than one area. Sometimes this depends on the design you want for your network. Now, these types of LSAs, type 1 describes the state and the cost for a specific router in that topology. And you know, a router can have more than one interface participating in the network, right? In the network. So if all the interfaces are in the same network, how we are going to the information about this router, right? The aggregate of the states of these interfaces is what is going to be communicated out there to the rest of the routers. And this goes in a topology. So if you're having a router in an area, if you're having a router in one area and another router in another area, they will not exchange this information, right? It stays for the router in the same area. Now, type 2 is called the network LSC, right? It describes is the same is the analog of type 1, but this time for the specific link, right? For the specific link. So it describes the aggregate link states and costs for all routers in a specific area. So remember, we said we can have more than one area. So if we want to have information on area, the backbone area, usually called area 0, can have like 3 or multiple routers or more than 3 routers. Now we want to know what is the state of that area. It is carried by LSA type 2, all right? And this is generated by what we called the designated router, all right? In an area, there is a bus router that handles that router. Mainly, most of the time, it is decided using the OSPF is going to calculate this using parameters that we are not going to delve in today. So this is shared with other areas through the designated router. Type 3 is called the inter-area prefix LSA. So this one will describe an area to routers in other areas, and it is generated by the ABR, right? The autonomous system boundary router, right? Let's say you are running OSPF protocol and you are running another IGP, let's say EGRP or ISIS. You can communicate these two routers, these two protocols. And the way you communicate this, you connect these two protocols is by using a boundary router, right? That boundary router will now be able to share information from various autonomous systems, as we call them. And then you have the type 4. Type 4 is used to carry information to advertise ASBR location. It is also generated by the ABR. And then type 5 describes distributed routes generated by the ASBR with the ASO, routes that are generated by each autonomous system. By autonomous system here, we mean routing protocol, right? So if you're having OSPF, it's kind of an autonomous. If you're having RIP, it's another autonomous system. So RIP has generated his route. OSPF has generated his route. How do you communicate this route? You use type 5. Then we go to new LSAs in IP in OSPF version 3. We have type 8 and type 9. These are the two new link state advertisements that have been added so that we can support IPv6. So type 8 advertises link layer addresses and prefixes to other routers. And the scope here is on the link, right? We already explained what a link is. So when you enable OSPF on a link, the other routers in that OSPF topology needs to know about the other routers that are in that topology, right? And to know these routers, you know them by their link layer address, by their link local addresses. And to advertise these link local addresses, you use type 8. And also the specific prefixes on each of those routers on that link are advertised using the type 8. And then the type 9 is for the intra-area prefix LSA. Intra-area, that is within an area, right? When you've configured, so all of these routers can sit on the same link. You can decide also that, although that on the same link, you decide to put them in separate areas, right? Or areas can also span across many links, okay? The way you share prefixes in an area is by using type 8 LSA. Okay, so these are the new features in OSPF, making it OSPF version 3 and being capable of supporting IPv6 routing. So how do you configure OSPF? Very simple. Very simple. So you start by configuring the second command. All right, no worries. No, there is a worry on this. You cannot use a PID that you haven't created. So the second command there, that is the IPv6 OSPF PID. The second one is configured under the in the global configuration mode. You want to create the process. So you enter that command, IPv6 OSPF, you enter the PID. Pick any number you want, 1, 2, 3, 4, 10, 100. Depends on your logic and what you want to convey as message there. Very important when you are configuring, OSPF for IPv6, always make sure you specify the router ID. Same for any other routing protocol that you are configuring. Why? You know, a router in a routing topology has to identify itself. How do you identify yourself? By the router ID. Now, the way these routing protocols are implemented is that most of them, they will look at all the interfaces on the router. If there is an IPv4 address that's configured, they are going to use that IPv4 address as their router ID. So don't confuse. The router ID is not an IPv4 address. It's a 32 dotted decimal dotted representation something. It's not an IPv4 address. I can have my router ID can be 0.0.0.1. All right. But now when you are configuring OSPF, ISIS, or whatever other routing protocol, is going to go and pick if you have loopback addresses, virtual addresses that are configured like loopback addresses and so on. If you have physical addresses that are configured, it's going to pick one of those and use as the router ID. Now imagine if you are in a greenfield IPv6 network where you have no IPv4 configured. What is going to happen? You are going to configure your cool OSPF, and then you are going to sit there and stare at your router. It's going to stare back at you. Nothing is going to happen. And when you are going to troubleshoot, you are going to be confused because you won't even imagine. Now, if you have like advanced troubleshooting skills, you're going to have the information, because if you do, like, if you start listening at the interfaces, right, you will see that your device is trying to exchange, is trying to establish that OSPF neighborship with their other neighbors. And then the information will be, oh, you are not having an ID. How am I going to identify you? You are going to have that information. And you do that under Cisco router by maybe enabling debug OSPF, IP OSPF. And then now it's going to be spitting out all the OSPF errors, and you see, oh, my router is not having an ID. So very important, always configure that. The next command, the IPv6 area ID, range, prefix, blah, 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 right? Tells you the area in which this router is sitting. So we know we have area 0, which is the backbone area. Then you can now start adding other areas like area 1, area 2, area 3, and so on, depending on the largeness of your network. Now, when you've configured this under the process in global configuration modes in Cisco routers, you now need to go on each interface and enable, right? Enable the OSPF. Okay? So we go back now to the first command. If you see, it is configure IF, that's interface mode. IPv6, OSPF, PID. This PID, remember, is that process ID that you created previously, right? It has to match, okay? So for each interface, you need to specify in which process ID it is in. And then you need now to specify for this interface which area it is participating in. This is how you enable IPv6 on the router, and specifically for each interface that you want to participate in your OSPF. And remember again, just to emphasize on this, don't configure OSPF with your customers. So you're having this router, it is connecting to your network, and then it is connecting to your customers. And then you come and configure OSPF on that router, you enable it on all interfaces, you are dead. You are dead. Because if you have bad people in your customers' networks, they are going to sniff into your OSPF information, and they will know your network topology, and they can kill you. That's why I'm saying you are dead. All right. Now, to verify OSPF, show IPv6 route will show on a Cisco device all the routes, the static routes, the OSPF routes, the BGP routes. Now, if you want specific routes, maybe BGP routes, you will add BGP in front, or OSPF route, or RIP route, and so on. And then when you have the routing table now, it comes with the information. This route was static, this route is coming from OSPF, this one is external, this one is coming from BGP, and so on and so forth. You can also view the topology of your network, right? Who are your OSPF network sitting on a specific router? Maybe you've just configured OSPF, pow, it's cool. And then when you go and do show IPv6 route, you see that you are learning some routes. Somehow you are not learning some other routes. Huh? So how do you troubleshoot it? You need to know who are the neighbors that are established here. Show IPv6 OSPF neighbor will show the list of your neighbors that are established, right? If they're established, now you see, oh, I can see that 3 of my neighbors are established, 2 are not established. Oh, this is why I'm not learning some of these routes. So let's dig down. Now you can also like do show IPv6 OSPF interface. This will show you all the interfaces that are configured in OSPF and their specific configurations. Okay. Show IPv6 OSPF database is going to show you the entire database. You know, each router, although I know all the information about my directly connected routers, I also know the information about the routers that are connected to them and connected to them and connected to the others and so on and so forth. And this information is stored in the OSPF database. And to view that is show IPv6 OSPF database. I can see there are some questions. Robert. Yeah. On the router ID topic, if you are using VRF, do you need to specify different router ID other than the physical router ID? All right, when you're talking about physical router ID, I hope you are not missing the physical router IP to the to the router ID itself. And what is VRF? VRF is actually you creating in a specific router instance sub-instances. So for each of these instances, you need to be identified, right? If you don't identify, by default, externally, it's going to use the physical router to be to identify. But for ease of administration, for clarity, right, you have to identify if each of the instances of your VRF. Merci. Over to you, Mr. Tunde. Any other questions, please type in the Q&A. Are you still alive? Did my PowerPoint kill you? Hello in the chat. Can I see hellos in the chat? Ah, yeah, thank you. You're alive. Yeah, merci. So far, so good. Let's move to the next slide.
I believe it's quiz.
I love this hello keep alive. That's BGP. No, not only BGP, keep alive goes for most of the protocols.
All right, we have 54 players. I think this.
Hold on. It's getting to the ceiling. Ah, yeah.
It's fluctuating now. All right, let's start a quiz. Out of 66.
So which of the following needs to match for OSPF v3 routers to form adjacency?
Adjacency, yeah. Clock is ticking.
Tick tock, tick tock.
Okay, so I see the answers here. Yes, Stephen did harp on the importance of a unique router ID to form adjacency. So yeah, that was one of the correct answers. I didn't mention anything about the hello and dead intervals, but this is another, it needs to match between the two routers. So the hello intervals keep alive, like you were saying, and the amount of time the router has to wait to consider that neighbor unreachable or dead, they have to match before they can form adjacency. So yes, so the unique ID, router ID, and the hello and dead intervals are the correct answers here. All right, so let's see the leaderboard. I think it was Strickland at the top before, Wesley Strickland, yes. Ian, I think I saw you last week. Okay, so you're here. Awesome. Ian has dethroned both. All right.
Good. Thank you for your patience and your attention. We are still alive. So now let's look at the configuration of OSPF. So this is an example of OSPF topology where we have 4 routers. And looking at those 4 routers, you can see that we have the backbone area called area 0, and we have area 2. So this is a multi-area OSPF topology. And if you look at router 2 is sitting in 2 areas with 2 different interfaces. Interface 1 is sitting in area 1, and interface 10 is sitting in area 0. And in area 0, router 2 should be able to talk to router 4. Meanwhile, the same router is talking to router 1 and router 3 in area 1. And if you look at these 2 areas, you will see that there are 2 separate links. There is one link here carrying the prefix. It's having one prefix, okay? And the prefix here is 2001 GB8 1CE/64. And the other side, we also have a /64 prefix there. And you see, while we're saying that this type of prefix is basically what we'll call address prefixes, right? Because this is /64 here, we'll advise you that when you are configuring your network on a link, always allocate a /64. Now, how would you get router 4 to communicate with router 1? You need to enable that routing, okay? And here we could have used static routing, but we are going to use what? We are going to use dynamic routing with OSPF v3. So let's look at the configuration now. What's the configuration like? I'll start with configuration on router 2. So on router 2, look at what I have here. Okay, remember I said in global configuration mode, I have to specify the router, the process ID. So here is 1, IPv6 router OSPF 1, that's the process ID. Now, the router ID, remember again, if you forget this, router ID 2.2.2.2. Then now, for this router, what are the interfaces that I want to participate in OSPF? So interface fast Ethernet 1/0 with prefix that prefix we don't even need to configure it here because this is how we configure IPv6. We should assume that this prefix is already configured and focus only on the second command there. That's IPv6 OSPF 1. Remember that 1 again is the PID that we created above. And then area, it is sitting in area 0. Interface 0 here is sitting in area 0. Interface 1, OSPF, same PID, but it's sitting in area 1. All right. Next. So now for this router 3, look again. Olatunde just told you that there are things that need to match for OSPF to form adjacency. One of them was that ID, right? The process ID. So here on router 3, I'm configuring IPv6 router OSPF 1. I can also configure OSPF 2, 3, 4. I can have many process IDs on that router. But how is this router going to establish neighborship with router 2? The process ID has to match. All right. And then don't forget the router ID. Okay. So router 4, same logic. All right. Router 1, same logic in terms of configuration. Create the process, go under the interface, specify the process ID and the area. You see here for router 1, interface first 10 is sitting on the in area 1. Okay. Next. And then the last router here. This router ID area 0. So we have two routers in area 0 and 3 routers in area 1. All right. So when you've configured this and it's cool, and each of them, these direct routers can talk to each other, they are now going to share link state advertisements, right? These link state advertisements, at the bare minimum, link state type 1 is going to carry the information about the states of each router and share with their neighbor. Now, when it gets to each neighbor is now going to aggregate this and build a database. This database, in subsequent updates, is going to be shared with other routers. All right? Yeah.
Okay, so Wesley, I'm going to, before I send you the slides, we usually send you the slides at the end of the session. I'll fix that typo, okay? And then for the anonymous attendee, excuse me, I didn't say the route IDs must match. I said the hello and dead interval timers must match. But you must have a route ID. That's the way you form an adjacency,
Yeah.
right?
Router ID must exist, but no, it cannot match. Two routers cannot have the same ID because this is an ID. It's unique for each router. Olatunde did not say they must match. No. Yeah.
All right, so I think we're up for another quiz. Excuse me. All right, we're 63 here right now. 54. All right, let's start a quiz. All right, so we're going to BGP, but before we start it, quizzing you on that. So which of the following BGP protocol versions is used in IPv6 routing? Okay, so as you can see there, BGP version 4 is the one that is used for that supports IPv6 routing, but of course with the support for address family. And I wanted to include that also when we were discussing OSPF. I forgot actually, now I remember. So you have OSPF version 2 for IPv4, We have OSPF version 3 for IPv6. We also have OSPF version 3 with address family. It has support for both IPv4 and IPv6. So in BGP, in this case, BGP version 4 has that address family support for both IPv4 and IPv6. So the correct answer is BGP v4, not v6, right? So let's see the leaderboard. Let's stay on top. All right, so let's move into the last section of this presentation then.
Yeah, we've talked much on internal or interior routing. And we've talked about IGPs. Now let's talk about BGP. So a quick overview of BGP, all right? I wish I knew who said BGP v6 in the previous quiz so that we can fight a bit. Yeah, but there is nothing like BGP v6, okay? There is nothing like BGP v6. There is nothing. Nothing. So, but there is BGP v4, right? That's the latest version of BGP. It's called BGP v4. 4 here doesn't stand for IPv4. No, it's the version of BGP itself. And this version of BGP, maybe tomorrow we might have BGP v5, BGP v6, and so on. It has nothing to do with the version of the address family. That's either IPv4, IPv6, VPNs, and so on. So BGP v4 supports address families, other address families, not only IPv4. And yeah, so it can be configured both for the payload or the transport. And this is what I'm going to illustrate here. So if you look at this topology, let's say we have this topology, right? Where we have these two routers, router 1 and router 2, even though it's not specified.
Left and right.
Yeah, left and right. So these two are speaking, they are BGP speakers. And the only way to communicate is IPv4. That's, you've established IPv4 BGP. What does that mean? It means in your configuration, in your BGP configuration, you've configured those two neighbors for a BGP, for an IPv4 BGP session, right? Okay. What is going to happen here is you can decide that on this IPv4 BGP session, you want to carry information about your IPv6 and your IPv4 networks. Don't do this. Because if you do this, what is going to happen is that in the next hop information is going to be an IPv4 address. All right. The next hop information here is going to be an IPv4 address for both the IPv6 and the IPv4 networks. And now, for your network to operate properly, you have to go and do extra configuration. For the IPv6 networks, for the IPv6 prefixes, you need to modify the next hop to specify an IPv6 address. Why do you want to do this? One day you might forget. Or what if you change something? It's bad. So don't do this. It's not recommended. This same scenario applies for a situation where you have an IPv6 session. That's on both links, you've configured IPv6 neighborship. And then you want to carry both IPv4 and IPv6 prefixes. What is happening here? What is going to happen is that the next hop here is going to be an IPv6 address. For IPv6 is okay, but what about your IPv4 networks? The next hop is going to be an IPv6 address, which is not good. For it to work, you need to go and specify again and modify that the next hop is an IPv4 address and specify that address. This is not recommended because if there are changes in the network, your network is going to break and you will not even know what. Remember, you have 1,000 things to configure on your network. You don't want that because you've changed this, it breaks. You have to go and manually be configuring your BGP again. You might even forget, you might even not know that, oh, this is why it is breaking. And you know, for us network engineers or even system engineers, we are very lazy and we don't want to be doing, we want things to work properly. And the easiest way to make things work properly is to keep them simple. So what do I recommend? On your routers, if you have to do BGP, separate IPv4 from IPv6. Carry IPv4 prefixes on IPv4 session and carry IPv6 prefixes on IPv6 session. All right. In this case, it's going to work. It's simple, right? For troubleshooting, when you want to troubleshoot, you go to the IPv6 instance, you troubleshoot. Oh, it's good. If you have problem with IPv4, you know, you go to the instance, you troubleshoot, and it's cool. All right. So how do you do this? Let's look at the configuration. So this is how you configure BGP, right? And I will shut up and I will ask you to type in the chat, is this IBGP or EBGP that you are seeing on your screen? I'll give you 1 minute. Take your time, look at this configuration and tell me, is it, someone say IBGP? Why? Why IBGP? And others, please tell us. Rowan, you are a spoiler. You are ruining our day. We needed to have fun to see people say EBGP. Good. Everyone is saying is IBGP. Why? Because if you look at the first command says router BGP 65,000, 65000, right? And then under that configuration, this thing means for that router, my ASN is 65000. And then I go now under the configuration, I say remote ASN. The ASN of my peer is 65000. Oh, I'm having the same ASN as my peer, meaning we are on the same ASN, right? We are in the same autonomous system. So here is how you do IBGP. IBGP, don't think that IBGP, there is another set of commands that are specific that you are going to say, this is IBGP. No, it's the way you configure that makes it BIO EBGP. So this is IBGP. And recommendation, always run IBGP on virtual interfaces, on virtual addresses. In this case, we are using a loopback address. Loopback 0 is a virtual interface. Why are we using virtual interfaces for IBGP? Tell us in the chat. Why? Why are we using? Yeah, thank you. Thank you very much. Mr. Daniel. So if you are having, you know, in network we say 1 is 0, right? 2 is 1. You always have to like be redundant. You're having more than one link to more than one route to go to various destination. All right. So what do you do here? When you enable OSPF on on um, on virtual addresses, what happens if a link breaks? The virtual address is still up. So there is a way that you can go to your destinations. All right. So this is cool. Now the next command that I'm going to emphasize on is the no BGP default IPv4 unicast. This is very important. BGP assumes by default, right, that you are doing IPv4. Sorry. So what is going to happen if you just configure your BGP without disabling that behavior? Is not going to handle your IPv6. So disable that for it to support the other address families, including IPv6. And then now you have to specify the specific commands for each of your neighbor, like telling what is your neighbor address, activating your neighbors, do some other tweaks like descriptions, security, filters, and so on. Okay, that's it. So we move on. Now, remember separation of address families, configure IPv4 separately from IPv6 for a lot of things: convenience, ease of administration and troubleshooting, problems resolution, and also if things change, you are covered. So in this case, we said neighbor, this activate. That's how you activate a neighbor. You can configure a neighbor and not activate it. It will stay there. You will not establish that adjacency until you activate. Now, boom, it starts sending keep alive and making sure that it starts sending echoes to the other router and requesting for information and updating everything. So this is BGP, and I hope this was informative. And I would like to thank you for listening.
All right. Thank you very much, Stephen. I hope all of you in attendance for the different style and flavor you brought here. You know, the energy and the fun, made it fun. With that said, I think we're in the Q&A section now before we take the survey and then I spin the wheel. So let's see. Any more questions? You want to talk, you can raise your hand. Sorry. Yes. The positions on diagram match those on the command. Malomula. Hope I got that correct.
Yeah, the prefixes on the okay. Did you find like any discrepancies? If there's discrepancy, there's that must be a typo.
Typo, yeah.
So it has to match.
I'm going to fix that before you get a copy of the slides. So, you want to talk? You can raise your hand.
So we are here. This is your talking time. Are you still alive? Can you please explain the answer for last but one question? Okay.
When was that?
Mr. Emmanuel, what do you mean?
OSPF question.
What's the question?
The OSPF question is it? Okay. Okay. I don't remember the question.
Is it the Menti question or a question asked by someone? Oh, the Menti question on OSPF.
What was it?
Is it BGP? Please, can you type the question back in the chat, please? Let's see.
Just give a hint. Was it the one on the neighborship forming adjacencies, or the one for the multicast addresses they use? Or did you say yes just now? I don't know. Yeah, forming adjacencies. Okay. All right. Yeah. I said so. There were two options that were correct there. And I remember I said you must have a unique router ID. And if you seen the topologies that Stephen presented, they had no router IDs of 1.1.1, 2.2.2 like that. You must have a unique router ID. And then your hello and dead timers must match. So router OSPF speaker A and B must have the same hello timers. That's the intervals they send keep alive or hello. And then the timer that A will consider B unreachable or dead, or the same thing, B consider A unreachable or dead. They must have the same for them to form adjacency. No, you don't. No, you must have unique router ID, not matching router IDs. The router IDs must be unique in the host, because you have to be unique in the OSPF system, right? Okay. You must have a router ID. That's the thing. It's compulsory. You must have a router ID, and it must be unique. Okay. Did the question say what must match or what is required from adjacency?
Is what is required. If it's matched, then that's a typo. Is required. So what is required is, first of all, each router needs to have a unique identifier, all right, which is called the router ID. The router ID needs to be unique for each of the routers. So if you have router 1, 2, 3, router 1 maybe router ID 11111, router 2 router ID 2222, router 3 router ID 5555, okay, router 6 router ID 0001, and so on. So you need the router ID. And you need also the process IDs to match, right? The process IDs needs to match. And then you need the timers to match, right? Because if you don't have the timers, if the timers are not matching, right, one might send the information early enough, too early or late, and the other one will not receive. So there will be a mismatch in the keep alive timing, all right? So it's very important.
So yeah, I understand where the confusion is coming from now. So I can see the question says match truly. So that was a typo. So sorry for that. All right. Yeah, so I understand now. So if you let me put the question on screen, if it's still there. So that is, oops. Okay, well, you can't see it, but I can see it. So yeah, there was a typo there. So it says match.
No, it doesn't have to match.
It
The
doesn't have to
router ID doesn't have to match. Correction.
Right.
Anonymous attendee. The router ID must not match. Okay? It must be unique.
Yeah, so I can't show you the, well, if I start, I don't want to mess up the leaderboard.
No,
Okay,
don't mess up. It's okay.
all right. So yeah, back to questions.
Other questions, please? Okay, if not question, Olatunde is going to perform a miracle.
No, I'm not going to. I'm going to invite you to take the survey first.
Okay, that's the miracle I mean.
Let's see. So as usual, hope that works. Hold on. Wait a minute. Sorry, I have a feeling this is the wrong one. Just double check. Okay. I'm going to quickly double check that shortened URL to be sure. I'm sorry. What I can see there doesn't look. Okay, so you can use the QR code. That one is correct. I'm going to post the shortened URL in the chat. Sorry. Yes, that is correct. That one is good because you can see by the code is saying LS3, that's live session 3, 27th of September. That's how I can tell it's not
Link
correct.
state 3.
That's how I know it's not correct. So the correct one, as you can see in the chat, is LS4, this one, second 0210, second of what's it called now? Yeah, that's the one I'm saying. This one is wrong. Okay. So yeah. So please the bit.ly link on top, LS3, don't use it. I pasted the correct one in the chat. Like I said, you can tell 2709. That was last week Friday for the last one. For this one is 0210 today. Oh, sorry. I pasted it to host and panelist. Sorry. All right, this is the correct one. I'm broadcasting it there. Okay. Just a very short survey, trying to set up the wheel of names here. All of you in attendance. So let me check how many of us have voted. In the wheel. Okay, so all right, we have 49 full completions. All right, so I think that is for the number of in attendance and the number we have there. Just have about 4 partial completions. If you can quickly complete that, please, and then I will put the wheel of names on the screen. So the link is in the chat. The one there is not correct. The date of ever, I think, is not correct, but the QR code is correct. All right, let's close it out now with the, excuse me, with the wheel of names. So let me see, let me put that here. All right, so I have 95 names in here I just pulled out of the attendance list on Zoom. So I'm going to spin it twice. Hopefully we'll be able to know the 2 lucky winners are in attendance right now. They didn't leave. So let's do this. First spin.
Emmanuel Boningaba. Are you here, Mr. Emmanuel?
Can type in the chat if you're here, Emmanuel, or you raise your hand. Be able to know. Otherwise, if he's not here, I have to remove your name and spin again. Oh, there you are, Emmanuel. Awesome. Okay.
Who is next? 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 Yeah, baby. Razan Altair.
I think I've seen that name before in the top 5. Or was it this one? I'm not correct. Yes, Razan, tell me. You've gotten one before, right? Or no? Yes, you've gotten. All right. So we need to spin again. All right. Thank you for letting us know. Thank you. All right, let's spin again. That means you're a very lucky man.
Edwards.
Yeah, come on. It's not that early.
Gofran. Gofran.
This is the new name. Yeah.
Gofran Talat. Are you here with us? Gofran Talat going 1. Gofran Talat going 2. Gofran Talat gone. He's not here.
It's not here. Sorry.
From Ronald Edwards Walker.
Okay. I don't know. Are you here? Ronald.
Ronald Edwards, are you here?
Raise your hand or you mentioned. Okay, there you are.
There you are, Mr. Ronald Walker.
All right. So thank you. So those are the 2 winners. And let's see if we have so that was a spin the wheel. All right. So again, thank you as always for sticking with us from that bumpy start for this workshop. And you're here again with us for the 4th live session. So as usual, you will get an email with a link to the recording, a link to the PDF version of the slides to download with the typos fixed. You will also get a link to the calendar to register for the last live session, which will be on Friday. Like I said, I didn't plan for this one to be this long. I wanted it to be shorter because now the live session, the learning management system is up. We expect you to go and take those courses, like I said when we started today, and complete them by October 25th. So all of you who are top 5 today, for example, and the lucky draw winners, the 2 lucky draw winners, you can only get those benefits or that benefit if you complete the 7 IPv6 e-courses before October 25th. And when I say complete, you need to complete all the lessons. I need to take and pass the final quiz in each of those courses. And the pass mark is 80%. I've been saying that, I'm sorry. I'll say it again. So, I don't know, Ronald, are you still raising your hand for a question or something? So, because the e-courses go further, because if you want to cover the whole thing in a session, it will be way too long. So, for example, the routing course that Stephen took over, Stephen authored, it meant it's more in-depth. You have configurations for MikroTik, for Juniper, I believe, and for Cisco, all for the routing protocols. Even ISIS that he says is his favorite is right there in that course. You see the configuration. It goes into more depth, all right? So this is just a recap. So the last one on Friday will be even shorter. So, but the mastering IPv6 transition mechanisms e-course is much more detailed. You have all the transition techniques in there. So, with that said, I'd like to thank you again for coming, attending to that. I hope you can hear all that going back in the background. So they're asking us to leave the studio now. All right. So thanks a lot. And I hope to see you all again on Friday for the last live session.
Merci. Bye-bye.
Yeah. Bye.